Recording. So tonight the topic is octave. Well, MATLAB really, but it's the same thing. So greetings to Eugene. I see you showed up, and Pranav. Okay, great. Okay, so thanks to everyone for coming. Oh, I should turn on the video of my face in case I need to do any gesturing. It's not 3D though, so I don't really have to do stuff with my hands as much. Okay. So I know some of you know Octave, or MATLAB a little bit, but I'm just going to try to give you a quick introduction to the language. So for those of you who know a bit, my apologies, but this is just a quick intro to the language and why it's so good for like banging out graphs of stuff and manipulating data. Right? So, all right, Octave and MATLAB are the same language but different libraries. So. This is the free one. I recommend it highly. The nice thing is it's always free. MATLAB, it's free for you now in school, but the moment that you get out of school, they want a lot of money. So the first thing, of course, is, well, you can just use it as a calculator, like 2 plus 3, and it just prints out an answer. 2 plus 3 times 4. So it does order of operations, everything you might expect. Now you'll notice that by default it's only displaying to 5 digits. You can say format long. And now you're seeing it to full double precision. So everything's double precision. There's no such thing as an integer by default. It's a calculator, so it's doing things like a calculator would. This is a programming language that does have loops. You can write for I equals... How do I do that? I forget. I think it's for I equals 1 to like that. But really, it's not good for this. MATLAB, I mean, you can do this when you absolutely have to, but it's an interpreted language, so this is slow. The fast way is to do primitives that become C code. So the vector primitives, when I could say A equal 1, and it stores variable A equal 1. I could say B equals 2, 3, 4, and it creates a list 2, 3, 4. And I can say C equals 2 semicolon 3 semicolon 4. So first of all, it's called MATLAB. It's matrix lab. So everything is vectors and matrices. But aside from that, it does everything really fast in C if you can give it a vector. So just to show you, I mean, I could say D equals 1 to 1 million or something. And if I put a semicolon on it, it won't show you the answer. But boom, it's there, right? It's really fast. And if I say size of D, there you go. I've got a 1 by 1 million vector. So it's really fast. Of course, it's a lot slower if I say D equals 1 to, I'll only do 1,000. Then it actually displays it, which obviously takes a lot longer. But so D equals 1 to 1,000 semicolon. What I'm saying is make me a list of the numbers from 1 to 1,000. Now that's a primitive. So it's very, very fast at making vectors, even if they're quite large. So I mean, my computer has 32 gig of RAM. Let me see what I can do here. D equals 1 to 1 million, 100 million, no problem, right? So that's how you can deal with large amounts of data very quickly. Yes, it's an interpreted language, but it's turning each individual line into a call to a vector function in C. So anything that's built in is as fast as C is. It may not be the fastest C code in the world, but it's still very, very fast. So, all right, so that's it. So what can you do with this crazy thing? All right, let's start with lists, a row vector. So A is going across the screen like that. Right? I guess I do need my screen. I can gesture with my finger. A equals 1, 2, 3 like that. B equals 2, 3, 5 like that. So we have A and B. So if I say A plus B, it does vector addition, right? So the plus sign works for both scalars and vectors. Minus sign works for both scalars and vectors. Of course, equals sign works. If I say C equals A minus B, that works for all scalars and vectors. But multiplication is different. So here's the problem. Everything in MATLAB is a matrix. So since this is a matrix language, you've got the problem that what does multiplication mean if you've got two vectors? Now this background will help us when we start doing the 3D stuff, because that's all, matrices and vectors too in 3D and under the hood. All right, so the operator star multiplies matrices. Now, if your matrices are 1 by 1, that's a scalar, no problem. But if your A matrix is 1, 2, 3 this way, and your B matrix is 2, 3, 5 that way, that doesn't multiply. So on the other hand, if I say B equals 2, 3, 5, if I make it a column vector, so now A times B, now that does mean something. So I'm going to do this with my fingers. A row going across, dotted with a column going down, we would multiply each one and add them up. So the product of, so this time it's, let's see, where's A? Wait, I don't have A, but A is here. So A is 1, 2, 3, and B is 2, 3, 5. So 1 times 2 plus 2 times 3 plus 3 times 5. What the heck is that? 1 times 2 is 2. 2 times 3 is 6, so that's 8. 23, all right. A times B, 23. Okay, so notice that you can't just multiply any two vectors by each other, because if they're not the right shape, it doesn't work. So in order for this to work, the first guy's rows have to be the same as the second guy's columns. So in other words, if you have 3 columns, I said that backwards, right? If the first guy has 3 columns in the row vector, then your second guy has got to have 3 rows matching up with it. Okay, but you can also say B times A, and that works. But that, as you can see, generates a matrix. It's not even the same dimension. Okay, so this time I'm going across every row of the first vector. In this case, there's only one thing. So 2, and I'm going down the first column of this vector, which is 1. So 2 times 1 is a 2. There's your answer. And 2 times 2 is a 4. And 2 times a 3 is a 6. So the first row of the answer is 2, 4, 6, which is the first number times each one of the columns there. The second row, we do the same thing. 3 times 1, 3 times 2, and 3 times 3, that gives us 3, 6, 9. And the third row is a 5, so 5 times 1, 5 times 2, 5 times 3, there you go. So the point here is that matrix multiplication, vectors are matrices, they're just really small ones. This is a matrix of 3 rows by 1 column. This is a matrix of 1 row by 3 columns. And if you multiply A times B, you get 23. And if you multiply B times A, you get this 3 by 3 matrix. And the reason both work is that in both cases, the middle dimension is the same. In the first case, with its A times B, it's 1 row of 3 columns times 3 rows of 1 column. So the 3 is the number that's collapsed, and we get 1 by 1. There's your answer, it's 1 by 1. And the other way, excuse me, the other way we have 3 rows on the first matrix, and each row gets multiplied by each of the columns. So that's 1 each. It goes 1, and there's 1, and there's 1. And I just do it 3 times, so we end up with a 3 by 3 array, but each one of these dot products was only 1 long. All right, so that's the definition of matrix multiplication. So you have to remember that when you're dealing with matrices in MATLAB, when you're dealing with variables in MATLAB, that everything's a matrix, right? So, but here's A, here's B. I'm going to just make C, which is 2, 2, 5, 1. All right, but let's say we have A and C, and we just want to multiply every element of A times the corresponding element of C. There is a way to do it, it just isn't the multiply operator. So MATLAB supports the dot operator. A dot star. So dot star doesn't mean matrix multiplication. Dot star means multiply every element of A by the corresponding element in C. And that's 2, 10, 3. So let's see. A is 1 times 2. So 1 times 2 is 2. 2 times 5 is 10. And 3 times 1 is 3. So there you go. All right. So you can put the dot in front of any operator. So let's see. A times C is like that. Divide is like that. Let's say we wanted to just square A, right? If you say A squared, that means you want to multiply the vector by itself. But if you say A dot squared, that means you want to square each element of the vector. So there you go, 149. All right, but if I say A squared, it says you can't do that because you can't multiply a row vector by itself. Okay, so that's like the basic math stuff. And remember, the most important thing once you start writing the code for real is you want to remember the semicolon, because if you do a list, let's say, okay, so we go from a 3, stepping 2, going to a million, going to 1,000. If I do this, you see every one. If I put a semicolon, you don't. So you definitely want to remember the semicolon, and I just extended it to a list. So a list is start, stepping value, and end. So notice the last one here is 999 because it did all the odd numbers up to 1,000. All right. Any questions? So we have data. We can manufacture lists very quickly. I want to show you how to graph stuff. The 3 areas I want to do tonight are, first, we just did the basic math, right? So you've got to know how to do this stuff. The second one is how can I graph data? Because MATLAB is great at just graphing data. And then if you want to graph data, typically you want to load in your numbers. So you need a quick way to get your text file into MATLAB. This is where, unfortunately, Octave is worse than MATLAB, but we'll have to live with it. So load your data into MATLAB or Octave and then plot it. All right, so let's start with, I think I did this in 390, so my apologies if this is a little redundant for some of you. Let's say I want to go from 0 to 2 pi. Let's go first from 0 to 10. So 0 to 10, and I didn't do a semicolon so you can see it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so let's say, instead of t, I could just say x. So x goes from 0 to 10. I want to make a corresponding y equals f of x, right? Let's draw a function. So pick a function. What do you want to do? X squared? All right. So I would love to write f of x equals x squared, but I don't know how to do so. So I won't do that interactively. I mean, you could do that in a program, but it's really too bad that I don't know how to do it on the line. At least I don't think it's available. Let me just try. Y equals f of x. I mean, that's how I would write it in a file. And then return x times x and end. Oh, I have to say function, excuse me. Yeah, I don't think it likes that. Maybe I'm getting my syntax wrong, but I don't think so. I think basically if I wrote that in a file, it would accept it, but it won't do it on the command line. So, oh well. So we just have to do it by hand. So y equals, all right. So how would we just, I want you to set y equal to x squared. What do I say? I'll give you a hint. It's not x times x. Okay, good. Y equals x period. Squared would work, or times x would work. Either way. All right. So now you got your y. All right. So now we're going to say plot x against y, and a window pops up. This is a bit slower on Windows. I don't know why. There's some really weird thing with MATLAB and Windows, Octave and Windows. So I don't know why this is slower. MATLAB is just faster in general. In fact, if you're running MATLAB, you're probably seeing like the all-in-one window, not the command line version. I'm using like the cheapo version. there is a version of this thing that has the environment, and I'm sorry, I don't even remember how to load it, and it's not worth my doing. But there's a GUI that looks just like MATLAB where you've got an editor built in. It doesn't matter. But anyway, yeah, it's there. I just don't remember how to run it. I guess I should just look it up. How to run Octave GUI. Is it just octave-GUI? Octave is started the command octave. Yeah, I know, but yeah, exactly. How to run it in GUI mode on Ubuntu, blah, blah, blah. If I can't find it, I'll give up, but is it octave-CLI? I thought no, this is octave CLI. So yeah, I don't know. Sorry. Somebody can find it for me. I mean, basically there's a window version that'll open a window with a command history and an editor and all that stuff. Anyway, all right, so the first thing is you can plot it, and I just told you it's really slow on Windows the first time. But once it gets loaded, it's a lot faster. So I don't know what's going on in Windows, but last I checked, it was still really slow. All right, now you'll notice that this graph is lying, right? It is not a smooth, continuous line. Oh, the function is, but that's not the data I have. I mean, you could actually kind of see there are a bunch of lines, they're bending at certain points. If you wanted to plot just the points, you could say X, Y, and you could give the thing you want to plot with, and it just draws the dots. Now they have a bunch of, they have star and period. Period is really small, and plus is a bit bigger. So you can control the markers, and there's like tons and tons of options for this stuff. So if you want to know, you can say help plot, and it will give you the command in here, or you could just go online and get it off the web, which is probably better at this point. So if I just Google octave plot, yeah, so you can get all kinds of examples and stuff, all right? So okay, so where were we? So first I said you could plot lines. Then I showed you could plot showing the markers, which are the, now I could also say I want these two things to be red squares. And I could say, oh, I'm going to show my ignorance here, but I think it's fill color is red. No, it didn't work. Did not like that. Okay, so there's an example. You saw when I got it wrong, it barfed at me, but when I got the right name of the attribute, I was able to set the size, and the squares are suddenly really huge. So there's like tons of these things. Again, you could look all that up. It's really great. But what if you want to draw the lines and this? So now you would say, hold on. So it leaves the current graph in. The normal default is every time you plot, it replaces what you currently have. So you say, hold on, and now you plot it again, and this time I'm going to plot X against Y. So now we have the lines drawn through, but we can see the squares surrounding where the actual data points are. All right. Now, suppose you want to draw two data sets, right? So how about y2 is equal to x cubed. All right, so now I'm going to plot x against y2. Okay, so now you see that the second one, it's drawing in red, which is kind of interesting. I think that's because I'm not sure why. This one got drawn in blue. Is it smart enough to auto switch colors? I guess it is. Here, let me do another one. Y3 equals square root of x. Plot x against y3. Okay, the problem is we're barely seeing that one. It's way at the bottom. Let's see. Y3 equals... All right, I'll make it 100 times the square root of x. Yeah. There we go. Okay, so yeah, it's cycling through colors automatically. All right. So notice how easy this is. It's really nice. You want to make a plot showing things. You say plot, 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 plot. And I mean, now maybe you think that, oh, I could do this just as easily in Excel. And it's true. What I've just done is manual. You could do it just as easily in Excel. The difference is that Excel, first of all, makes lousy graphs. Excel's default styles are horrendous. And if you make a paper using Excel as your graphing tool, everyone makes fun of you because it's like submitting your homework in crayon, like a kiddie thing. Maybe it's unfair, but too bad. That's the way life is. So, all right, I could set the title. Okay, so you notice now up at the top of this graph, there's a title, but the font is really small. So yeah, we can do all that, right? Font size 24. All right. So why is this so great? Well, for one thing, we can label the axes. Oh, sorry, it's X label. Excuse me. Okay, so you can barely see it. My apologies, but there's a... Oops, I said y-axis, x-axis. I should have said y-axis. Okay, I may not like their defaults, but... All right. So the point is you can set up a graph. So now... What makes MATLAB such a killer tool? It makes it better for graphing your data than most other things. It's the idea that we can write a program and save it, and then we can, use it over and over again. So, edit. I think there's a built-in editor here. You can configure it to run whatever your editor is. So let's see. Edit. Test.m. Okay, and I'm set up to run Emacs by default. So there it goes. Now notice I'm in octave mode already. That's Emacs for you. It put this horrendous comment in the... This is the default stuff that they've set up, but I can get rid of all that. Ooh, it's read only? Well, that's weird. Okay, I will unread that. There we go. All right. So test.m. Okay, let's say function test. Okay, so now we're going to write a function. So let's say you had some data. Now we got to make up some data. All right, we can do x, y, y2, y3. We'll just take the data we had from before, right? Okay, so now we can say close all, which closes all the windows, so that this graphical window would go away if it was up already. We could say plot x against y, hold on, plot x against y2, plot x against y3. Yeah, I guess I should put semicolons so it shuts up. What else do we do? Oh, X label, Y, right. So I could also grab my history, but here, just grab that. Grab that. Okay, so now you've got a program and all right. No. Oh, these idiots, where are they? Okay, it's defaulting in the wrong place. Okay, so Git course workshops octave right there. Okay, so we're here, ls. So notice, the file commands are Linux style file commands. That works even in Windows, by the way. But I think dir also works because, yeah. So they try to be like Windows friendly. But basically, whichever system you're on, both commands work because they write little stuff to get it working. So here I am, and I've got tests right here. And if we say test of x, y, y2, y3, there we go. So close the window, open this new window, which I could drag bigger. All right, so I don't know if you appreciate how much better that is than Excel. But if you try to do this in Excel, you'll be like a monkey cutting and pasting stuff because you can't automate it. But this thing that I just did, we could write a script and apply that 100 times to 100 different data sets. And we could do it a lot faster than Excel. So this is designed to make scientists' life better. It's really, really good. Any questions? Anything I can help you with? You know what? I didn't put in. Comments in this language are percent signs. All right, and now if I run it again, you'll see the window actually go away and come back. Okay, of course it comes out each time in the wrong place, which I don't love, but that's like, I could program that too. All right, so then we should learn a lot more graphing functions, all the crazy cool 3D things you could do, which is amazing. Just want to show you, you can save the picture, but you don't have to save it by hand. That's what's so cool about MATLAB. You can also just say save as name, and you can just pass in name, save it out. All right, so now it's just test.jpg. Oops. Did it not go? I don't see it. Oh, whoops, I called it wrong. Excuse me. Ooh, save as GCF. Get current figure. So that's the current picture. So that was an error. Did I get an error there? Yeah, print usage. It gave me an error. I wasn't paying attention. So it says you have to tell me which thing, which handle, and then what file name. Let's try that again. Test.jpg. All right, let me see. I have GNOME. Test.jpg. I don't know if I have. I don't have I have GNOME. No, I'll trust that it works. All right, so this is unbelievable. If you're trying to do a research project and you suddenly find you need to do 100 graphs, this thing will let you like blast that out in minutes, and you don't have to like think about it. You just anytime you can put out a text file, you can read it in and plot it out. So I guess that's the next and final piece of this. How do you read in text files and plot your data, right? So let's see what I got actually. We got some data in here. For the workshop, I know I had grabbed a whole bunch of cool stuff. Global warming. Now I want to do a little more historical provenance. I don't know. Okay, yeah, this is kind of cool. So I just grabbed some random data. This is like what people do in MATLAB, right? You got some crazy random data. So this is some station off of Providence, Rhode Island. It's telling you where the latitude and longitude is, and it's giving you it's a weather station. So what is it giving you? You know, the problem is I don't even know. What the hell is this thing? Oceanographic. So is it temperature? What? Looks like this is temperature in centigrade. And it's water, so it's kind of like, it gets cooler, it gets warmer, but this was 2020 May. Yeah, so the water temperature was 19. It could be air, I don't know. So, sorry, we can look at this later and see. Station ID, in the unit. Degrees centigrade, but of what? It's whatever. Now, the point is, it's data, right? So how would you get around doing this? So, you can get fancier than I'm willing to get at this point, but MATLAB in general has much better data processing stuff in the libraries than Octave. In Octave, it's a work in progress all the time. They're always playing catch up. But the bottom line is, if you know that you're always getting this same thing up front, even in Octave, I could just say skip those first few lines, right? But I think in the interest of simplicity, I'm just going to do it by hand. All right, so we're just going to like save this out. Oh, it says air temp? Thanks, Andrew. All right, cool. Where do you see that? Oh, AT, description. There we go, description. Air temperature, AT, haha. Very good, thank you very much. Okay, so I mean, this is a classic data set, right? You're given data, and your professor says, graph this goddamn thing for me. And you just want to do it with a minimum of muss and fuss, right? So in this case, I mean, definitely if you're going to do 1,000 of these, it's probably worth your time to figure out how to strip off this garbage on the front. But if you're just doing a one-off, just save this out. Let's write this to stripped Providence Rhode Island.txt. All right, and I'm just gonna now that it's in a new file, I just get rid of that stuff. Okay, so now that we have, oh wait a minute, we got other garbage here. Okay, so now we have a unified data set. Of course, what I love about keeping the other data in there is that you can read it and find out that it's air temperature. But okay, what we have to do now is read this and throw it out because I don't know what it's the station ID. We can throw that out. This, I don't know what it is, but okay, they're telling us that it's air temperature, so it's always air temperature. I don't care. The relevant things that we're interested in is it was on this date at this time, and the temperature was this. Oh, I see. This is all like in a few days. Wait, 1 day. Okay, it's a time series over 1 day, and this is every 6 minutes. So it's midnight, 6 minutes, 12 minutes, 18, 1 a.m., etc. Okay, there we go. Okay, that's why the numbers were so similar. I mean, if we get it over a year, we'll see numbers going down in the winter and up in the summer and all. All right, so this was just the diurnal, getting colder at night, hotter in the day thing. So yeah, 25.8. This is like 70 degrees-ish Fahrenheit, and at night it was cool, air temperature. All right. So what we want to do to plot this, and this is very typical for scientific data, we want to get the date and turn it into an X coordinate, right? That's what you need to know how to do. So what we're going to do is just load the damn thing. I'm going to do it by hand, and then you can always write a script to do this. So here we are. So if I say load, stripped, wait a minute, where did I write it? It was in a directory. It was in global warming. Okay. So I can load global warming / stripped. So notice I was hitting tab to just autocomplete that auto completion of files is the best thing ever. And it works in here too, not just in regular Linux. Okay, so now the question is, when you load that file, where do you want to put it? So we could just say RI equals that. So our variable, unable to determine file format of, oh brother. All right, see, this is where MATLAB would just kick this thing's butt. All right, you know what they don't like? They don't like the AT. We got, if it's just numbers and dates, it's okay, but I think it's not happy about that. I swear it should be able to handle, but again, I'm just gonna I want to do quick and dirty stuff, so I'm gonna say control spacebar. Whoops. Control spacebar. Set the mark there. I'm gonna try to just delete the ads, and in Emacs that's real easy to do. I'm just gonna go here to the end of the column and just say Control X RD, and I just deleted the column. Let's see if I can just get it to shut up there. No. All those bastards. Alright, that I wasn't prepared for. Huh. That is annoying. Yeah, in MATLAB this would just work. I don't think so, but I'm willing to give it a shot. They should be very, very tolerant of that sort of thing. I don't know what the hell it is, frankly. Like I said, in MATLAB this just works. And I just haven't played with this stuff in too long. Why doesn't it know? Alright, so set a mark here, go down to the bottom, Control X RD. Okay, get rid of one there. Okay, wait. CD global warming. Load. Fail to read matrix. Okay, wait. So I'm gonna. Let me just try a separate file for a second. Test.txt. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and actually 1.5, 2.6, 3.1. So if it's just every line is exactly 3 columns, I don't think we're gonna have a problem here. Load test.txt. Yeah, no problem. So what's the difference? Okay, wait a minute. We had a date there. It might be that they don't like the date, which would be rude, because that's the beauty of MATLAB. But okay, it's octave. They got their problems. So I'll just put a date in the front of each one to test out this theory. Yeah. Okay, so they're barfing on the date. That's really unfortunate. All right, well, I'm sorry about that. I don't want to look this up right now because it's too slow for me. But maybe I'll do that in an extra session sometime. Let's start with this. No, wait a second. Let me just put the dates in, and let's try to do the dates by themselves. Because that's fun. The fun thing to show you, actually. Load test.txt. No problem. Because it treats those as strings. Goddamn. All right. So if I load test.txt, then the variable by default is the name of the file, which is test. Okay. So, yeah, it's really confused as to what that means. It thinks that that's like -5, and then it loses the rest of the line. That's pretty stupid. Okay, so these guys can't handle date format, which is really, really unfortunate, because I'm not going to do the whole thing by hand. That's ugly. What I will do is 529, 528, 529, 530, and 531. So I'll just show you what it would look like. Test. There we go. Okay, so, and again, Octave is not handling the dates well. There is definitely a way of doing this. There is a load columnar stuff in Octave. It's just not that good. MATLAB is much more robust. So here we go. Test. Okay, so if you can just get the columns right, you got, there's your date, there's your hour and minute. Okay, so what you'd have to do, of course, is write something that would read in your data and massage it into this. And what I'm telling you is, no, you shouldn't do that. You should find out what to do in Octave In fact, let me just quickly look it up, but I'm not going to like try to get it working because it'll take too long. So, octave, how to read dates in file. All right, let's see. Yeah, so that, right, exactly. There is a CSV format reader, DLM reader, right? So you can do this. All right. And clearly it can handle like that. It can even handle nulls. That's kind of interesting. All right. So what you should know is this: when you have a date, you need to turn it into a number, because you don't want to plot dates. You need to plot numbers. So there's a function called datenum that turns any date into a number. It's called the Julian date. That's a really useful concept in science. It turns it into a double precision number that represents the number of days since some point. And generally speaking, I think the datum they pick is January 1st, 2000. No, you know what? I lied. They picked January 1st of the year 0, which is fake. There was no year 0. So let's see. Datenum of 0. Let's say of the year 1, January the 1st is 367. So yeah, they're saying our starting point is somewhere about the year 0-ish. A little before, actually. 1, yeah. Okay, now, so if we're saying, the year 2000, January the 1st, was obviously quite a few days since then, 730,000, but it's a good absolute number. And then if you're at 12 o'clock on that day, then it's 0.5. And if you're 30 minutes after the hour, you add that fraction. And if you're at 26 seconds, so that's the thing, right? So your Julian date will give you like microsecond accuracy for any kind of scientific data that's like, our time frame, last couple hundred years, that kind of thing. Probably go 6,000 years out. So you could say, where is Jupiter going to be in the next 6,000 years? And all that stuff is done with Julian date. I have somewhere here, I have the Jan Mias's astronomical algorithms book. I used to have that in my office at school. Jan Mias. Here I could just show you the link. Astronomical algorithms. And this guy, does Julian date to death. This is a good one to know. So I will just paste that in the chat. All right, so with that, you're going to be able to plot a time series, because every date and time will turn into a number that you could plot. I'm not going to do that with you right now because we're short on time. So we're just going to, oops, why did I do that? Octave. All right, what I'm going to do is try to plot 3D stuff. I showed you how to load the file. Let's now do 3D stuff. Okay, wait, close the astronomical algorithms thing. Let's look at my editor up here. Kill the text file. We're not going to do the text file, but you know how to do it now. CSV read should be, it's DLM read or something crazy like that, but that's a good one. All right, so how can you plot some cool 2 and 3D color maps? All right, first thing I'll just show you is, let's make a random matrix. You might ask why, bear with me. A equal rand of 10. If I say I want a random 10, it's not a random number from 0 to 10. It's a 10 by 10 matrix of random numbers. So I have 100 numbers. And it's printing out, they're all between 0 and 1. So if I don't want to look at it much, I'm going to say rand of 100 and I'll say semicolon. That's 100 times 100, or 10,000 random numbers. Now that's a lot of numbers to look at. So I'll show you your first 2D color command. P color of A. So what we're going to do is draw the matrix, and for every number we're going to assign it a color. There we go. I'll magnify that so you can see it a little better. All right, but we don't know what the colors mean. So the next thing is we'll say color bar. All right, so now you have a key that shows you that 0 is dark blue and bright yellow is 1. So that means that this greenish thing is like dead center. And you notice it's pretty random, right? I mean, hopefully the random number generator is good. So let's just do a quick experiment on this. What do you think is going to happen if I say a equals random of 100 plus random of 100 plus random of 100? What will we get? Nope. Here, I'll give you a new one. There's the graph. Notice I wiped out the old graph. So I'm graphing it. What's the range of numbers now? If each one of random numbers could be from 0 to 1, what's my range of numbers that I can graph? Well, each one's 0 to 1 and 0 to 1 and 0 to 1. So if I get 3 1s, I could have a 3. And if I get 3 zeros, I could have a 0. So my range is 0 to 3, right? So we'll do a color bar, and now you can see that dark blue is 0, and yellow is, well, it doesn't show you, but 2.5 is here. So that's 3.0. All right? But notice we're getting very few yellows, right? Now it's starting to look, pretty middle of the road green, right? So it's not as random as the last time. And if I do it again with 5, it's even more. So it's trending toward the middle. This is a bell curve. Whenever you add a lot of random stuff together, you can expect, because on average, right, of those 5 numbers, they're not all going to be 1. So it's very unusual to get a 5. And you can see there are many fewer yellows now than there were when I had 3, and there are even fewer than when I had 1. When it was 1, it was pretty evenly distributed. So this is you're getting a bell curve now. Can I say histogram? I think it's hist. Sorry. So now you can see, isn't that cool? You could just graph it and you can see that, yeah, there's a lot of guys in the middle, relatively few guys at the top or bottom. Okay, so that was the first one. I could turn a value into a color. So we could take a 2D distribution of values and we can make a color map. And you could use this if you have a map with XY values. You could take a map and draw it, right? So if you have a map consisting of rectangles, but you would obviously have to assign. You have to know what the latitude, longitude of each place on the map. So yeah, we could make a map, but I'm not going to do that. That's definitely something to try, though. All right, next cool thing to try. XY equals mesh grid of -50 to 50. All right, wait a minute. Let me do a small one first so you can see it. Let's go from -2 to +2. All right, so mesh grid is a function that will generate for you x and y values in a range in a rectangular grid. So the x is going from -2, -1, 0, 1, and 2, and the y is going -2, -1, 0, 1, and 2. So together you could think every cell, this is -2, -2, and this one is 2, -2, and this one is -2, 2, and this one is 2, 2. So for each corresponding pair of xy's, you've got a coordinate. You could think of it as being laid out in a rectangle like this. So now we could calculate a third variable in terms of those two. So we can make a function of 2 variables. How about z equals x times y? That's not x times y. Something's very odd because I'm using matrix multiply. No good. What do I do instead? Z equals x dot star. Y. Yeah. It's okay. No. These are all negative 2s. These are all positive 2s. These are all, right? So when the mesh grid function, let's go back to that one. When I said mesh grid, I'm saying make me a grid where the coordinates go from -2 to +2 in each direction, and generate me x and y variables, right? So I can draw a function in 3D. Let me do a bigger one. I'm going to go from -50 to 50. So in other words, we have 101 numbers going from -50 to 50 in each dimension. 101 times 101. So the matrices are going to be quite large. What's the size of x? It's 101 by 101. What's the size of y? It's 101 by 101. Now if I say z equals x times y, semicolon, it's going to compute a corresponding z for each x and y, which is also a 101 by 101 matrix. And now I can say, show me the surface x, y, z. And there you are. So this is the visualization of that surface. Now if I click here on this guy here, I can, oh, oops, wrong one. I want to rotate. You can look at it from all angles. Isn't that cool, right? So there you can see, if I look at it from the top, it looks kind of like a P color, right? But it's not a P color. You can see it in 3 space. So I've visualized, scientific data coming back from the field and oceanographic data. I've made 3D maps this way. It's awesome. All right. So, I mean, remember, how complicated was this thing, right? It's x, y equals mesh grid. Oops, sorry, semicolon. X, y equals mesh grid. Z equals that. Surface. That's it. Right? So that's pretty spectacular. The fact that you can, in 3 lines, graph a 3D surface, and all you need to do, of course, is to get your own surface from data, and you can graph it in 3D. Now, you'll notice that there's a lot of black lines here, so it gets kind of obnoxious. If I do 250 to 250, let me do a different one. How about r is equal to the square root of x squared plus y squared. Okay, so basically I'm calculating the distance from the center of the grid. And now z is equal to the sine of r divided by 5. I don't know. Let's see how this goes. And surface XYZ. I believe this is going to look like a sombrero. Okay, so it's wiggling a bit too much, but yeah, so you see at the origin it's 0, and it's going up and down as this is circular waves traveling out. And you can sort of see it on the edges. It's kind of cool. So we can have fewer waves if we say z equals r divided by 50, or r divided by 20. There we go. But you notice there's a lot of black lines here because there's so many boxes now. There's too much black line relative to the thing. So this is a cool one. You could say shading interpolate. So you're saying is don't show me the black edges, just smooth out the color between them. And you get this gorgeous 3D surface. You can still see little defects in here. It's not perfect because it was granular, but it's pretty amazing. So the point here is that MATLAB and Octave let you do 3 major things. One is you can just graph data, which is good. 2 is you can load the data from text files, and okay, I had a little trouble here tonight, but it basically showed you the right principles. You can load your data, massage it to get the stuff you want, and then you can plot it. And then you can do 3D stuff, and you can write functions to automate all this so you don't have to keep writing all this code. So you write a function and you just apply it 100 times. And so this lets you automate processing of your data. You can do this in Python. You can do this in many systems, in Mathematica. But MATLAB is, Octave in particular, is free. It's quite easy to learn. It's fast. I mean, Python is almost as easy, I think, because with Python, you have to kind of know Python first a little bit, but then there are libraries in Python that try to emulate this. So you can do almost as easy in Python as this. I think overall, I would say this is easier than Python, but if you like Python already, then the cool thing is look at how you plot data in Python, the MATLAB libraries, and you'll see that there's similar stuff. But anyway, whether you use Python or this, I would recommend having this in your toolkit, because this is what happens, right? You're in my data structures class or something, and you want to plot some data, and you don't want to spend your time writing some program. You just want to quickly do it. This is the way to do it. All right, so any questions? That's going to be it for the night. I just want to give you the core of what Octave is and how you use it. And I think I've done that. Any questions? All right, so you'll notice that in the Octave directory in the workshops, there are all these data files that you can like play with. So I had like, a map of US counties that you could load CSV files. So yeah, I was clearly aiming to load CSV files in Octave. And can you plot various things? Population statistics. Again, I just downloaded a bunch. So this was just me pre-downloading last year a bunch of cool things, sample data for you. But I warn you, data is ugly. It's complicated. It has mistakes in it. So whenever we look at one of these things, yes, it would have been worth our while to like strip out, figure out how to like parse that in, and we did strip out the data from historical provenance. But yeah, you're going to end up with problems like, oh, I've got that thing. Oh, one line is missing one piece of data. What do I do? There's always going to be these kind of issues. So if you think you're going to just like load data from some COVID data site and be able to just plot it with no problem, you're going to have problems. So you need to be prepared for that. Data is messy. Real data. That's one way you could tell when somebody's faking their data, because it's too good to be true. All right, so thank you very much. That is it for tonight. Plenty of cool things for you to do if you wish. I hope to see you all tomorrow night. I'll send out an announcement to remind people, but what's tomorrow night's topic? Blanking. Oh, Nancy's turn. Sorry? Oh, slicing. Right, of course. So I've got to prep that too. Okay. Yeah, so that's it. 3D slicing tomorrow. Seeing how you turn your model code into G code and print it on a printer without the printer button. All right. Thank you.